Alright, so now we need to interpret this velocity time graph. We can definitely see a trend where the average velocities over each little time interval is getting greater, which is good, we're seeing that idea. But we want to draw a best fit line and really come to a conclusion or an understanding the difference between something we call the average velocity and another idea that we call the instantaneous velocity. And this is a big word, so it takes me a while to write it. Now the average velocity is exactly what we said. It's our change in position over time. Our instantaneous velocity is the velocity at that moment in time. So think of it as looking at a speedometer. When you look at the speedometer in a car, you see that speed slowly increase, and it tells you exactly how fast you're going at that second. But if I wanted to figure out my average velocity, I would take how far did I go, what my displacement was, and I would define it by my time. So we have two different ideas. And what we want to do with this graph is say, okay, I know that this car was increasing its speed as it went along. And if I think about it a little more, I know that it wasn't going a certain velocity the entire time and then kind of jumping up to another velocity. You wouldn't see that on a speedometer, that you're first going 10 miles an hour and then suddenly you're going 20 miles an hour for a little while, but you can feel yourself still speeding up and then your speedometer jumps over to 30 miles per hour. That's not what happens. What your speedometer does is kind of a smooth increase all the way to 30, 40, 50 miles an hour. So that's what was happening with our constant speed car, and we want our data to look a little bit more like what we would expect. So let's look just simply at this, what's going on in this first step. This first average velocity in the first tenth of a second, where it was going on my graph about 13 centimeters per second. So that would correspond to, on my spark timer tape, of this first dot from 0 is what I called 0 to the tenth of a second. Now if I were to zoom in on that, we're going to zoom in now, and I were to draw my 0 dot there, and then maybe my tenth of a second right there, and then my 2/10 of a second might be like way off the page over here because I'm really zooming in on it. If I were to somehow have a different kind of spark timer that could take samples not at 10 hertz, but actually there's a switch on your spark timer that goes up to 60 hertz, which means it does 60 dots in a second. So could you imagine, instead of having 10 dots, you would have 60 dots? So you'd have 6 more dots in between these two dots here. And what would that look like? Well, these wouldn't be evenly spaced. It wouldn't show you constant speed in the interval. They would also be doing something like this, where they're getting a bigger distance or spacing between the dots. And that's basically the idea, that how we want to get from an average velocity to an instantaneous velocity. If we could shrink our time interval down to something super small, it would approximate, or really it would reduce to, the speed at that exact moment. So it turns out, if we were to do all those dots, and I'll put my time axis here, my velocity, and let's say I have, this was my tenth of a second on my graph, and then you had the other steps over there. If I were to shrink down these time intervals, you would end up having little steps like that would just kind of go, and there'd be one right in the middle there, like that. And it would get closer and closer to being just a point. What's the speed at that instant? So that's the basic idea of how we look at this velocity time graph. We want to approximate that, yes, I know the speed is increasing. It's not some same velocity the entire time. It's actually increasing. But this is representing the average over the whole time interval. So what we are going to do in our graph, to cut to the chase, you're going to pick the one right in the middle, right there, and make your dot. So this would be halfway between 0 and a tenth of a second. This would be 0.5 seconds. And you're going to make your dot. And you're going to do this same thing for the one up here. So let's draw it on the big graph. So I'm going to make kind of fairly good sized dots so I can see them. Right in the middle, right on that line. And you go through and do the rest of them. And those are the dots that you want to draw your best fit line. Okay, so remember, when you're drawing your best fit line, make sure you're not just trying to connect all the dots. Make sure you're taking a good, careful measurement and trying to get just as many dots above the line as below the line. That's really important when we are looking at experimental data. Good luck.